far we discussed what happens, how to get the magnetic field due to an element of current. But what now if you have a long wire? And again, the wire can't just start from nowhere and end nowhere. It has to continue in a complete circuit. I'm just looking at a segment of a long piece of wire. And you want to now get the magnetic field at a point like point P. How would you do that for this wire? Well, we know how to get the magnetic field due to an element of the wire. So if you take this element that has element of length ds, and the r hat unit vector, remember, it points from the element to the point where you want to find the magnetic field, and r is the distance between the element and the point where you want to find the magnetic field. So this dB would give you the magnetic field at this point only due to this element. But what now if you want the magnetic field due to the whole wire? How would you do that? Well, if you look at some of the different ds vectors and r hat vectors for different elements, for this element, that's the ds vector. For this one, it's this one. You can see the ds vectors are all different. They don't have to be the same for different elements of the wire. And the same thing with r hat unit vectors. They always point towards the point where you want to find the magnetic field, but they don't point in the same direction in space. So if you want to then get the magnetic field due to the whole wire, you would have to basically add the magnetic field due to this part, plus the magnetic field due to this part, plus this one, and plus this one. And basically then you need to do an integration. So you need to integrate the magnetic field contribution over the whole wire. And during this integration, the ds vectors are not the same everywhere. They're variable. The r hat vectors are not the same. The distance between the point and the element of current is not the same everywhere. So it's actually quite a difficult thing to do. We're going to focus in this course on problems that are relatively easy to solve. So don't worry about that. But in general, it's not very easy to get to do this integration.